Hello again and welcome to another lesson in the Designing VMware Infrastructure video training series. In this lesson, we're going to be discussing a critical turning point in the process of designing VMware environments, and that is mapping the logical design to actual solutions. In this lesson on mapping the logical design to actual solutions, we're first going to review the various things that have brought us to where we are right now. We're going to review the key concepts that we've discussed and covered in the course up to this point so that we can summarize and now begin to move on to the next step in the design process. And that next step is this idea of mapping solutions onto the logical design. We'll then take a look at exactly how we go about doing that, examining how to map solutions. And then I want to focus in on two specific topics as we round out this transition lesson, and that is we'll take a closer look at selecting solutions and then a closer look at analyzing for design impact as we wrap up this lesson. Now that we've seen an overview of what we're going to cover, let's dive right in. As I mentioned, this lesson is a key turning point in the course. Prior to now, we've been talking about abstract principles. Following this, we're going to be talking more about specific solutions, specific products, and specific technologies, and how we go about assembling those or mapping them onto the logical design. Before we can move into this key turning point, though, I first want to review what we've covered thus far. Early on in this course, I asked you, where possible, to watch the lessons in order because some of the lessons build upon concepts and ideas introduced in earlier lessons. With that in mind, if you've watched the course in order, then you recall that we've already discussed the idea of the design factors and how we go about determining the design factors. The design factors being our requirements, our risks, our assumptions, and our constraints. And I introduced you to the idea of how, as an architect, the design has to satisfy the requirements, minimize and mitigate the risks, identify the assumptions, and adhere to the constraints. Once the design factors were determined, and I showed you how to go about determining the design factors through a requirements analysis and an assessment of the current environment or an assessment of the workloads you anticipate being placed into the environment, then the next step was to take those design factors and craft a logical design being a high-level, abstract representation of what the design needed to look like and what the design needed to do. And this logical design encompassed a number of different areas, including a logical compute design, a logical storage design, a logical networking design, security solutions, backup and availability solutions, and a management layer. And I provided lessons on each of these sections, so that there was a lesson on creating the logical compute design. Likewise, there was a lesson on creating the logical storage design, crafting the logical network design, selecting security solutions, selecting backup and availability solutions, and designing your management layer. All this information up until now has been based on using the design factors to create and craft a high-level, abstract, logical design of the environment and what you want the environment to accomplish. Now we need to take the next step in the overall design process. So if you have your design factors determined and you have your logical design created at this point, then what is the next step? It's now time to map that logical design onto actual solutions. Recall that the logical design is a high-level design. It's an abstract design. It, in most cases, does not specify particular technologies, particular solutions, particular products. But in order for us to build an actual VMware infrastructure design, we're going to have to select actual products, actual technologies, actual configurations. And now we're going to take what we've done with the requirements and the risks and the assumptions and the constraints. Now we're going to take what we've created with the design factors, and we're going to begin to map these requirements and these design factors and the logical design that resulted from them onto actual solutions. As I mentioned already, it's a pivotal turning point in the design because now you're going to be thinking in a different way, and there's a different set of processes that you will follow in order to perform this function. With that in mind, let's take a look at the four-step process that I've defined for how we go about doing this thing called mapping solutions onto the logical design. Mapping the logical design to actual solutions is, as I see it, a four-step process. That four-step process involves selecting a solution, evaluating that solution against the design factors, the risks, the requirements, the assumptions, and the constraints, determining other areas affected by the solution, and then analyzing for design impact. This four-step process, however, is an iterative process as well. It's not something you're going to go through once. You may have to go through it multiple times. And you may have to go through it multiple times because, let's face it, we all know that there's more than one way to solve a particular problem. In your logical compute design, you specified how many megahertz or gigahertz and how many gigabytes of RAM. And we know, intuitively speaking, that there's more than one way to fulfill that requirement. So we might have to go through this process multiple times to determine what is the right solution based on our design factors. Now I'm going to go into more detail in each of these four steps. So let's start out by taking a closer look at selecting the solution. In this four-step process that I've defined, the first step is to select the specific solution, product, technology, or configuration for a particular design area. And you're going to do this for each area of the logical design. I have examples that I will share with you in other lessons in this course, so I won't go into a great level of detail here, but at a high level, here's a couple of examples to think about. If you're mapping solutions in the logical compute design, then you might be selecting a specific server platform or a specific server form factor. We'll go into that in more detail when we delve into specifics around how we map the logical compute design onto actual physical compute solutions in another lesson. In the storage arena, we might be choosing a particular technology like deduplication or data tiering as a solution that we're mapping into the logical design. And again, I'll have more details on each of the major logical design areas in other lessons in this course, where we'll be able to spend more time talking about the particular details for that design area. Let's now move on to the second step in our four-step process. In the second step, once you've determined or selected the solution, you're then going to evaluate the solution against the design factors. You're going to evaluate the solution against the guiding principles for the design factors, the risks, the requirements, the assumptions, and the constraints. And you'll do that by looking at the solution and how well it fulfills the logical design and the specifications of the logical design, and asking and answering questions like those shown here. For example, does it satisfy the existing requirements? If you've chosen a particular technology, then you have to look at that technology and evaluate it against the requirements and the risks and the constraints to say, does it fulfill these design factors? Does it create new requirements? Would the use of this particular technology or solution create new requirements or new design factors that have to be incorporated? Does it adhere to the constraints? For example, if you've been given a constraint to use a particular vendor's technology, does it adhere to that constraint? Or did the solution that you selected come from a vendor other than that which was instructed or given to you in the constraint? Does it introduce new risks? If you've chosen a particular storage technology, does it introduce risks anywhere else? Does it introduce risks to your backup or availability solutions? Does it introduce risks to your performance or functional requirements? Does it mitigate existing risks? If there was an existing risk that backups were not going to be completed within the time window specified, would the technology or product or configuration you've selected in this process, would it mitigate that risk? These are the sorts of questions you need to ask yourself as you evaluate the solution against the guiding principles for the design factors. Now let's look at the third step in this process. The third step in this process is to determine what other areas would be affected by this particular choice of solution. This is something that I've discussed with you in a number of instances throughout this course in various lessons, and it can be evaluated or examined by asking questions, sometimes even just simple, straightforward questions like, what other areas are affected? Brainstorming and using techniques like mind mapping or listing or diagramming can help you uncover what other areas might be affected and help you uncover how many other areas would be affected. The reason we want to look at not only what areas are affected, but also how many areas are affected is that will give you an idea of the scope of the impact for this particular technology choice. And if the scope is too great, then you might need to go back through this process and look at a different technology or product or solution in this place. Again, I've shown you a variety of techniques here. We've looked at mind maps, we've looked at diagrams, we've looked at lists and tables. Use whichever technique you find most effective. Now let's move on to the last step in the process, which is analyzing for design impact. This is the last step in the 4-step process, and it is a very important and critical step in the process. You have to ask yourself questions like, how are the other areas affected? In the previous step, you identified which areas were affected. Now you need to look at the question, how are those areas affected? If I determine that storage affects networking, how does storage affect networking? If I determine that compute affects storage, how does compute affect storage? In what specific ways does the particular technology or product or solution that I've selected affect other areas of the design? This is a critical and extremely important part of the overall process. As the architect for the environment, you need to make sure that you continue to think holistically and consider the entire design. Consider that all of these areas are inextricably interlinked and will have lots of relationships and lots of dependencies in other areas. Your job is to elaborate on all those dependencies, explore all those dependencies, and make sure that you can account for the various ways in which the design will be affected by various choices in these areas. If you determine in this process of analyzing for design impact that the impact of a particular technology choice or solution in this process would be too great, would be too significant, then now you have to go back and iterate through this process again. Let's consider an example. If I select a particular compute platform, and in analyzing for design impact, I realize that that's going to affect my virtual network design, it's going to affect my logical network design, it's going to affect my storage protocol, it's going to affect my storage design, and it's going to affect my number of hosts that I need to have and the number of clusters I'm going to use. Well, then I might determine, the scope of this particular impact, the number of different areas that are affected, and the significance in the way that these areas are affected, and then the significance of the way those changes affect other areas, creating this ripple effect, is so great that this isn't the right solution for me. That's the point and the purpose behind analyzing for design impact, is understanding and being part of the process of determining which solution is the best solution. And in fact, I'd like to just stop and talk for a minute about this process of selecting solutions. How does one go about selecting solutions? Is it a random thing? How do you know which solutions you should select in a particular design area? Well, the bad news is there's no magic bullet. There's no secret process here. You have to go through the appropriate steps and do the appropriate research to determine what the right solution is. So you'll have to determine what potential solutions are available. When you're selecting compute platforms, what are the various compute platform options from which I can choose? You'll need to do the appropriate research and analysis to determine what are the advantages and disadvantages of each potential solution. What are the prerequisites or dependencies for each potential solution? What are the relationships of each potential solution to the rest of the design? Because that will in turn lead you to the design impacts of each potential solution. Now, if you've been in the industry for a while, you already have a pre-existing body of knowledge upon which you can draw in making your selection choices. Perhaps you have experience with a particular server vendor, or a particular storage vendor, or a particular networking technology. you can draw upon that experience in selecting solutions. Perhaps you work for a company that has relationships with a certain set of vendors. You're going to have experience with those sets of vendors, and you can draw upon that knowledge and that experience to help you go about selecting the solutions. If you're new to the industry and you don't have that pre-existing body of knowledge, then this process is going to be a little more difficult for you. It's going to be a little more time consuming because you have to go through and do the research. You have to go through and dig up that information in order to be able to make these decisions. Yes, it can be hard work, but it is the work of an architect. It's what an architect does. Recall from another lesson in this course that I introduced you to the concept of the fact that an architect is different than an administrator. An architect has a different role and a different function than an administrator. And here in this instance, we see that illustrated very clearly. The role of an architect is going to be very, very broad and looking at lots of different solutions and looking at the relationships between these different solutions to the overall design. Analyzing for design impact is another key skill. I've said several times in this lesson that it is critically important and imperative that you master the ability to understand the impact on the design of the various design choices that you make. It's a recurring theme that you have seen and will continue to see throughout lessons in this course. And I've shown you, or attempted to show you, that there are a variety of ways, a variety of tools and techniques that can be used to help you uncover relationships and help you uncover design impacts. Some of these have included the use of mind maps, tables, diagrams, lists. These diagrams may be hand-created or created in Visio. Similarly, mind maps might be created using a mind mapping tool or simply handwritten. But either way, the idea here is to explore the knowledge that you have or that you have gathered to understand the impacts of the various areas on one another. As with selecting design solutions, if you've been in the industry for a while, this will come a little more easily. If you're new to the industry, then there is going to be a fair amount of research here to make sure that you understand how each of these potential solutions works. This also comes from a deep and thorough knowledge of the products and technologies that are involved, which is why, as an architect, it's important to have a good, solid understanding of the building block technologies that are being used here, a good, solid understanding of the underlying virtualization technologies as a VCP or otherwise, a good, solid understanding of server and operating systems, a good, solid understanding of storage and networking will all come in extremely helpful as you go through the process of analyzing for design impact. This wraps up our turning point lesson as we now prepare to shift from logical design discussions into more detailed physical design discussions. I've introduced you in this lesson to the process of mapping the logical design to actual solutions. We started out with a review of what brought us to this point, the design factors, those being the requirements, risks, assumptions, and constraints, and the role the design factors play in creating the logical design, which we've been discussing up until this point. Next, I introduced you to the next step in the design process, which is the idea of taking that logical design now and selecting actual solutions and technologies and products. We call this mapping the logical design onto actual solutions. Following that, we took a closer look at the four-step process that I defined for mapping solutions. And then I delved into two areas in particular detail. One on selecting solutions, how do we go about actually choosing the solutions that we're going to evaluate and analyze, and next on the actual design impact analysis, which is a key part of the architect's role and worthy of some additional consideration. That concludes this lesson. Thanks for watching.